Hello everyone. Today I want to explain how we can co-simulate ADAMS model with MATLAB Simulink if we need it. I need it here to apply a controller to my model, and for designing a controller, ADAMS is not appropriate, especially a nonlinear controller. Uh, when you have a model which is nonlinear, it's better to have a nonlinear controller and design it in Simulink. But before co-simulation, we should check two important issues. First, your Adams version should be compatible with your MATLAB version. For checking this, you should go to tutorial, check which versions of MATLABs are compatible with your Adams, or install the appropriate version. Or going for a newer version of Adams. It depends on you. And after that, you can't export files and co-simulate with MATLAB. That file has problem. When you simulate it in Adams, it raises an error. So you should fix and address all of the problems in Adams, and then exporting files and co-simulate it with Simulink. Before that, you can do it because MATLAB stops if your model has problem in Adams. For this, I simulated. I want to show you my model can work and doesn't have any problem. Sometimes error is related to your modeling, how you model, how you actually create your joints, connect them, or put your forces, everything related to your modeling in Adams. But in other cases, it can be related to your step size. If it is not appropriate value, too low or too high, especially too low, not appropriate for complexity of your model, you should change this. You can reach appropriate value by trial and error. And sometimes it can be related to your simulation type. Your model has dynamic nature, but you define kinematic or static simulation. So it's better to put this on default. Adams can easily recognize your model needs which type of simulation. And you should choose this one. Start at equilibrium. It's related to you. If you want, you can activate it. I don't need it. But the second option should be activated because if we create some changes in model and then go for another simulation, this option, if it's activated, if it's enabled, it regards the latest changes. And for seeing animation, for seeing visually your model during running, you should enable these options: upgrade graphics display and interactive mode. I run it, and you can see in the beginning there isn't any problem. But if you have serious problems at the beginning, an error would be raised and your model is stopped. For addressing problem, you should check here, view command window, or press F3. Usually error appears the last part of text in command window. You can make connection between the last part is checked by Adams and your error. But usually Adams doesn't say you directly which source creates error. You should guess that based on your experience and where the error appears, after which part of your model error appears. And the next step is defining inputs and outputs. Inputs and outputs means we need some inputs that calculated in Simulink. We don't define them in Adams. And outputs are usually information data of sensor. We have some sensor for measuring, for instance, forces, or for measuring Euler angles, which are very important, or positions. And we need to send this data to Simulink. Simulink, if we use controller, should actually calculate deviation from our target. If our deviation is a desired path, like path following scenario, so it regards based on information of sensors how much we deviated from this desired path and how much torques, I mean inputs, should increase or decrease to reach or to back to the desired path. I define them in here in elements folder under system elements subfolder. I try to categorize them by adding out and int at the end of the names to define which are inputs, which are outputs. For instance, I open this, this this should have value. This is value of value which is measured by sensor. And for instance, this measures steering angles of rear right wheel. So this bar shouldn't be empty if it is output. Output of your ADAMS, or in another word, input of your Simulink model. This shouldn't be empty. You should define it. Maybe constant value, maybe value changes by time. You can write an expression based on time, or you can use information of sensor you used. But input elements, you put 0 because these values should be defined by Simulink. These are your inputs, usually torques of motor, servo motors. And we have 10 motors here, 4 for steering, 6 for creating traction force. So we need 10 values should be imported from Simulink. After checking this, we go for the final step, plugins tab, controls, plant export. And when this window opens, you should define a name, or you can use the name that Adams defined. But if you change the name, you should copy paste this name after the name of the model. Exactly here. They shouldn't be different. I didn't need initial static analysis, so I put it as default. I don't need to activate initialization command. This part is very important, defining input and output signals. We have different ways for doing this. If it is first time, you can easily type or copy paste the name of your elements you need here. This is for output. We can do the same for input. Pressing enter and adding the next element and create your list. Or you can go for easier way. Right click and this blank window, Adams variable, browse, and choosing your needed elements here, one by one or a group of one. You want to remove some of them, just press keep control. And you can do it for input signals too. But if it's not the first time you do it, you did it before, and you change your Adams model, and again want to export files and co-simulate it with MATLAB, Adams has history of your previous controls plant export. You can use input list, output list of previous models. So I just need to press this button from P input. These are previous control plant export models, and if I open one of them, and if you don't change inputs and outputs or its their order, if they use the same output list and input, you can go for this option. It is easier and even more precise. An order is appropriate if you design your controller. Again, you want to change Adams and give actually an export a file from it. Order of these signals are important. Don't change order. It should be exactly in this order. And the next step is defining which software we want to co-simulate with Adams. Here, by default, is on Easy5, but we want to change it to MATLAB, so we should change it. Analysis type is by default on nonlinear because majority of systems need nonlinear analysis. But if your system doesn't need, you can put it on linear. It's faster. I don't need to change which language Atom Solver is used. C++ is better choice than Fortran. It's faster. And then we OK it. Adams created 4 different types of files used for co-simulation. But where? They are saved in a directory you define here. So before exporting, first you should define the directory. I defined this folder. I defined it previously, so I expect to see exported files here. As you can see, we have 4 new files here. Adam file, Windows command, M file, and text file. It's better to save all of the files in same folder. Do not split them. It's better to put these files in a folder that you have your Simulink file and your Adams file, bin file. I opened my MATLAB before I just go for running the created M file, exported one. When you run this file, you can see inputs and outputs you define in Adams with the same order are listed here in command window. And this order is important when you want to connect your inputs or use your outputs. The number of signals are important. Then you should type Adams underline this, and Simulink raises a block for you. This is Adams plant block based on your model, based on M file. If this is the first time you want to use this and apply it for actually your controller, it's better to copy paste it thoroughly and transfer it to a new Simulink file, not working here, and design your controller and apply it on this block in a new Simulink. So just you need to copy paste it and here you can apply your controller. These are your inputs and outputs, and they are defined by ID number, the number you saw in MATLAB command window. But I designed my controller before. Here, I connected all inputs and outputs. You can see names are the same, order are the same, and we have 10 different inputs and outputs in this way. Which outputs are used in which block of our Simulink defined here. But if you change your Adams and you want to actually transfer a new model to your Simulink, to your controller Simulink model, you don't need to copy paste this block again and again, make connection, connecting your inputs, connecting your outputs from the beginning. This is very time consuming and it's not needed. You just need to copy paste this block. This block representative of your Adams model. So I go to my Adams sys here, copy paste this, and I prefer not change this file. Just close it without any changing. Remove the previous block and replace it. This is enough. You don't need to do it from the beginning and make connection from the beginning. It's not needed. But for defining setting, how you want to information between Simulink and Adams exchange in each step, you should open this block, and in window of block parameters, you can define how do you want to make connection with Adams. You don't need to change this or even this. C++ is good option. But about animation mode, usually we have problems in the beginning when we run Adams. Maybe MATLAB stops suddenly because of an error, and usually error in would be in Adams. You should read the error to find a source, whether error is from your MATLAB, from your control design, or from Adams. If it is from MATLAB, from Adams, it's better you put it on interactive for the first run till you become sure that your Adams model doesn't have any serious problem. It's better to put this on interactive. You can real time watching your Adams when your model is controlled by Simulink, and where it stops, and guess what is the source of the problem, and change or modify your model in Adams to fix it. So I put it on interactive mode. Discrete is good option, it's precise, and I don't change other things, other options, but this is very important. Communication interval, you define your step size. It means after each time, after each period of time, Simulink should send information to Adams and give sensors information from your Adams model. Here, after 5 milliseconds, we have data exchange. We have connection between MATLAB and Simulink. It depends on complexity of your model. If your model is very complicated, it shouldn't be high value, such as one. One connection in each step is not enough for a complicated model, and it would be stopped. It would be stopped because Adams cannot solve dynamic models. By trial and error, as I said it previously, by trial and error in Adams Simulink, in Adams view, you can define an appropriate value. Here, in each step, we have 200 connections between Simulink and Adams, and this is appropriate, this answer for my project. After changing setting, here we define time needed for completing a scenario, and then you can run it.